Hey everybody, it's Paul Grossman, the Dark Arts Wizard of Test Automation, the guy who takes down dragons wherever he can. And we are here at another Tech meetup. I'm really happy that everybody could join us today. I hope you're having yourself a fantastic Wednesday, I believe it is. I'm kind of losing track of the days here. We've got a great session for everyone over here, and I hope you're all enjoying it. I do want to give a quick shout out to Tech. Again, thank you. I believe this is coming up on 2 years that we have been doing these meetups every month or two to get new people out here to talk a little bit about test automation, testing in general, and how to make your life so much easier. I do also want to mention, I mentioned this last time I was here, I wrote a book on test automation. So if you're trying to learn something in TypeScript or JavaScript and you want to use WebDriver IO, that's pretty cool. This is Enhanced Test Automation with WebDriver IO. I wrote it with my co-author Larry Goddard. Larry also hosts these conferences every other time, so it's always good to hear from him. And by the way, I want to make one other mention. If you're not into that, there's another book out here called Software Testing Strategies by Matthew Huser. Also a fantastic book read to get in there. I would recommend you guys take a look at that. Hey, I've got an alarm that says it's time to start our show and talk a little bit about it. We always talk about manual testers, automation testing, all sorts of tips and tricks on how to get things done correctly out there. And by the way, if you are kind of a manual tester, but you don't want to learn how to code, I'm going to give it one other pitch. There's a tool out there called TestRigger. It's actually a cloud-based automation platform. You can type things like click the add to cart button and it'll go and find the add to cart button, and you don't have to learn stuff about CSS and XPath. So that's my pitches for today. We've got, starting off here, we got Szilard Szell out here who is going to be joining us for the next hour and giving us a whole bunch of information on his talks over here. He is a great guy. Check him out. Look him up on LinkedIn. He's got a lot of great credentials out there with what he does. I'm going to ask our guys in the back, see if we get Szilard up here. All right, there he is. Hey, Szilard, how are you doing?
Hello, Paul. It's really great. It's brilliant, sunny in Finland for the last 5 minutes. Uh, we are just enjoying the fourth or maybe the fifth winter this year. It's been snowing last night this much. So, yeah, lovely, perfect. This is what I love in Finland.
Well, I have a visa and a visa. I've got to get my travel card punched for Finland. It's on my to-do list. It sounds like a wonderful place and lots of friendly people, and it sounds like I speak the language. So that's always a plus for me. I always joke about it. I'm a typical American. I have 5 different accents, but I speak only one native language. So I'm glad you smiled at that one. Szilard, I am going to turn it over to you, and we'll have it's about an hour, 55 minutes to do whatever you want, and we also have Q&A at the end. I'll be monitoring some of that QA. Everybody on this, also make sure you can either watch it here or you can watch it on, there's a YouTube link as well that you can watch it from. With that said, Szilard, it is all yours.
Thank you so much, Paul, and thank you for having me here. So I was surprisingly realizing that my color fully fits the Zapotec color as well. That's just a coincidence. So as said, I'm a Hungarian living in Finland for 6 long winters now and counting. Today I wanted to talk about actually a story that I collected in my last 24 years in the testing industry, more like how testing has been developed, how I went through developing testing, or how it evolved actually. And based on that, how I've seen it grows in technology, in different things, and capturing that, what I see people, testers should know, should learn in DevOps. So actually how testing is evolving on DevOps, but also how shall we evolving ourselves. Before we go into that, I would very quickly give a bit of an introduction of HeFi Code, the company I'm working for. So we are a leading DevOps company in Europe, experts in cloud, DevOps, agile, and service management, software development as well. And mainly we help customers with transformation into real software-driven organization. This is where I work as well. I'm a DevOps transformation lead, focusing on advisory and coaching within the team, especially on quality assurance aspects. We work with the big names, a lot of them, and we are in more and more countries. As you see, we are also in the US and in some of the major European countries. About myself, so I'm a DevOps transformation lead with a really big heart for testing and quality assurance. That is where I started in testing. You mentioned, Paul, manual testers. Yeah, I was kind of one of them from the early ages of 2000, starting with telecommunication systems testing, scripting as well as, but running them manually. Let's put it that way. No CI/CD, some scripting, some coding, and then moved a lot. So like have been all around in those years. I'm a change agent. I feel myself as one who is pushing for change and helping people on multiple areas. Because of that passion, I'm always also a member of multiple communities. One of the ISTQB, the International Software Testing Qualification Board, that is certifying testers around the world. So I was president of the Hungarian board, then still volunteer and working in there. Well, I'm also collecting things like I'm collecting Lego, but I'm also collecting certificates. So some of my way of learning is actually to get certified in things, and that gives me the knowledge. Then I go back many times to actually teach those things, so that helps me to understand better, especially during those discussions and conversations with different people. If you want to see more content from me, scan this QR code, or later on I will have, I suppose, if I remember correctly, I will have my contacts. All right, so what we will do today, we will go through a bit of few points. First of all, we will start with a survey in Metrimeter. So let's see that how many of you are out there, and let's see how much involvement we will get, interaction on that one. Then I want to do a very quick DevOps refresher, talking about the three ways of DevOps and then how testing fits into that. But then we would go through a more detailed flow of testing aspects and quality-oriented aspects within the DevOps flow. Then I want to show quickly a balanced quality model that we are, or I defined or work with. So based on all this, the presentation, I want to sum it up in actually 1-2 slides, and then a bit of a takeaway. So that's the plan for today. And then let's start with this question: what testing in DevOps means for you now? So please either scan the QR code or go to menti.com and take this code and go with it. I will start my talk. I will go through the DevOps. You will see the QR code and the little code in the corner like this. So please take it. Please answer the survey, and we will come back later after my intro to DevOps. We'll come back of what do you mean is testing in DevOps. So a quick refresher on what is actually DevOps, and maybe and probably everybody is already knowing this. I want to give a bit of my view on this one. But yeah, let's start from the very basics. So the DevOps is a solution for the big wall of confusion, right? We have two organizations. We have the development organization, and then we have the IT organization. The IT organization, whose task is actually to make sure that the systems, the solutions, the services are stable. They are incentivized for stability. On the other hand, development is incentivized for change. Their task is to provide value. Their task is to initiate or understand problems, reflect on problems, reflect on opportunities, and create value, right? Then value is delivered in changes, typically. So if we talk about an agile team, the agile team is expected to have potentially shippable product at the end of every iteration. And when we make it not only potentially shippable, but really shippable, then it means that IT needs to make sure that the systems are changing all and all again. And that actually creates the wall of confusion. There's a big problem between the two. So the very simplistic solution, wow, surprise, is that we bring these two together. Well, surprising. But is this the solution? So if we look into DevOps as a solution, it means that now we pull together Dev and the Ops into the same team, or at least collaborating and working together. Depending on the size, on the scale of the organization. Of course, this could be extremely difficult, or this is something that we need to figure out how it works. But when we talk about DevOps, and when we talk about merging Dev and Ops teams, should we also think about merging them with business? So when we have the DevOps and with the star in the middle, should we think about Dev BizOps? Or should we talk about Dev Management Ops? Or should we talk about Dev InfoSec or DevSecOps? Or do we want to talk about Dev Test Ops or Dev QA Ops? Now, what I believe, and this is my feedback, please note, DevOps includes everyone in the organization. If we scale DevOps, and if you look it from the value delivery point of view, value flow, value flow acceleration point of view, then everyone needs to be involved from the organization. Every different aspect, every different role who is there to realize an opportunity, to identify which way to go, to break it down to backlog items, and then also on the other side, when it's already deployed, to manage it as a service and even have the customer discussions and the service desk running. So all of them needs to be here. So why I'm saying we don't have these dev, biz, manage, sec, QA, IT, ops type of things. We call everything DevOps. Now, based on the DevOps guideline, the DevOps book, Jim Kim defined the three ways, or talks about DevOps through the three ways. Where the first way is the principle of flow, right? The principle of flow of value from left to right, from business to customer, answering an opportunity and making sure that developers can provide a solution quickly to a problem through operations into really the customer's end user's hands. Now, if you look into testing in this one, the first way, testing could be seen a bit maybe as a bottleneck of the flow, because we need to do all those testing. We need to do all the quality assurance steps. We want to make sure that before we deploy to production, nothing is broken. So this is extremely important to see that testing can contribute to the flow as well, with lean practices, with testing practices that are supporting this incremental value delivery, the agile practices with very fast cycles, short cycles and fast cycles. Now, if we look into the second way of DevOps, the principle of feedback and amplifying feedback, we can understand that on one hand, it's extremely important to get learning from the end user, from the customer, on how this new value is actually being taken, how is this new value, new piece of functionality is working. But also, not only from the end user, we need feedback, but actually from all the steps of the pipeline, all the steps of the activities that are after each other. So that would mean that we need to give feedback on, for example, the quality of the requirements. We need to give feedback on the quality of unit tests, the actual functionality, how it works, also on how the operational environment is scaled up and how is it running. So amplifying feedback is extremely important. And again, testing and testers are the one who can provide a lot of feedback on here. I would say we are not just, providing test case results like pass failed, but we are giving information, and we are giving also feedback on compliancy, feedback on how much we believe and feel that the quality is already in place. So feedback is important. Testing is, and testers, the testing mindset is extremely important to build and provide this feedback. Now, the third way is the principle of continual learning and experimentation. There's a statement that if you can't out-experiment and innovate your competitor, then you are doomed, you are sunk. You need not only to learn like what's good and what's wrong, you need to identify what's the next opportunity to go. Now, testing and test thinking could provide a lot of help on this one as well. Quickly get prototypes into the hands of the end users, into the hand of the customers. We can gather feedback on, for example, usability, on user experience, on the quality of the solution. But also, just as a tester, asking the question, what if not? We are already providing feedback, and we are actually opening the eyes of everyone with test first thinking and supporting to understand the possible bottlenecks, the possible risks, but also opportunities. I found that testers are very good to support the service design area as well. We will get back to that. So the three ways of DevOps is important, but testing has a role in all the three ways as well. So all the roles in the three ways, again, amplifying flow, amplifying feedback, and making sure that we have continuous learning and experimentation in place. Now, looking into DevOps, we could say that one of the view, this is from Tricentis, a pretty odd picture, to be honest. They stated into this DevOps Infinity Loop, or added testing as a continuous testing part. Now, I mean, this is good, but I believe this is not enough. For me, testing and quality assurance, quality view is much more than just continuous testing here. So looking into another picture from Dan Ashby, and this is like from 2016, you have the links as well there. After a conference, he was like always thinking like, this is a nice picture, all the blue one that was described about dev and ops, but where testing is. And then he also stated that actually we don't need to have a testing step, because we test here, we test here, we test everywhere. So I could relate to this one much better, and I like this picture much more. Now, before we go on, I wanted also to say that when we talk about testing and quality, we also have the DORA DevOps metrics, right? The DevOps, so Google's DevOps research and assessment teams creating this report every year about DevOps. And actually the success of DevOps are measured mainly with these four KPIs or metrics. And now there is a fifth one, which is reliability. So if we look, then the first one, lead time for changes, is exactly in line with the flow, with the first way, right? Mean time to recovery. Okay, let me come back. So change failure rate. It's not enough if we are fast, right? If we can very quickly deploy into production, we also need to make sure that those are actually good. So first we speed up and we try to be faster, but then we are also looking how many times we delivered something wrong. So we look into the change failure rate to understand that are we having proper quality assurance, proper safety net within our pipeline, with our way of working, to make sure that we provide high quality code, high quality solutions. Now, in case we don't deliver high quality solutions, the question is, how quickly can we recover? How quickly can we have our services up and running again? How can we have mean time to recovery as small, as short as possible? And then, of course, deployment frequency is also important. So not only how long time does it take for a change to arrive to the customer, but how many times, how frequently we are delivering changes. This is like how small increments, for example, we can chunk the problem so we are able to deliver small pieces of value continuously to our end users. So before we go into now more deep into the testing part, let's look into the Menti. And I already see we have a few answers here, not too many, honestly, but we have a few things here. So what is testing in DevOps in your point of view? So it states like value driver. It's very good. Testing could deliver value and support in the value delivery, right? That's what we want. Fast, easy, quick delivery, faster delivery, absolutely. Safety net. I like this statement, safety net, because I see that our testing, or the tests what we do, or the questions what we ask as tester mindset people, it's a safety net. Precise communication, feedback, commitment, turnaround, irritative. Oh, testing is irritative. I love that one. I would like to hear more, maybe in the message as well. You can just chat me what you mean with that. But if testing is slow, it can be irritative, right? If you need to wait for the testing to happen, that could be annoying, definitely. All right, good. We will come back to this one. I will actually switch to the next one already, but this is no time yet to look into that. So what is testing in DevOps, and what I believe is testing in DevOps? But when we talk about testing, should we actually talk about quality assurance, or should we talk more about quality assistance? Quality assistance as a concept of helping everybody to have built-in quality mindset, and in every phases of the life cycle of the software, making sure that quality is built in and quality is then preserved, measured, preserved. And in case of there's a quality problem, we can get back quickly to recover the service. So testing in DevOps. Let's look first our development value stream. So if we open up the DevOps infinity loop, what we will get is a flow of different working steps. Now, I love to start with design, where design is service design. Design is design thinking, understanding the customer needs, understanding what they want. Then you plan which problem to solve first, which is the area to go. You plan, you design, you have some kind of breakdown of the problem into smaller areas. Now I just see, pause, that irritative is not irritative, but iterative. Great. Better. So when we talk about the next step, it is like designing and understanding, chunking the problem creation, the solution into smaller pieces. Then we go into coding, building, testing, deploying, releasing, operating, and monitoring. And you see, I stated deploy first and only release, because I believe that we continuously deploy that, but we release only on demand when needed. Now, we also operate in the live environment, right? And for that, we monitor continuously the environment, but also the usage, and we actually monitor to understand if the value that we wanted to deliver was actually delivered. So it's really monitoring on multiple areas. So let's look into this one. If you look into the picture, what do you see? You see that we have actually testing as one step only, right? It's in the middle. And I would really say that this is not enough. So what I wish to see that we shift to the left, but we also shift to the right, but actually we shift even more to the left and even more to the right. So really to the far left, far right. We are not talking about politics. We are talking about testing here. So far left, far right, and making sure that we start quality thinking as soon as possible in the life cycle. But let's go through these areas because I like to structure the testing activities, the testing needs based on these different stages. So if you look into the testing part, what are the areas that the tester needs to know? What are the areas that are now important in DevOps testing? So first of all, Trisantis was right. Testing moved into continuous testing. We are running our tests more frequently. We expect to have really stable automated tests, non-flaky tests, something that is easy to maintain, easy to run and rerun and rerun and rerun again and again. That is actually built on keyword-driven test automation. We need typically keyword-driven test automation. This seems to be the best way to automate tests because keyword-driven also gives us opportunity to talk more with the business, that business is understanding test case description by just reading the tests, the executables. So it's not a spaghetti code script which is ununderstandable, not just very tiny steps there, but more like in the business language, in the problem domain of the end users, we are doing automation. We will go a bit deeper into these actually in the next slides. But when I say, for example, we do automation and we need more test automation for continuous testing, test automation also gives us the opportunity to do more exploratory testing or bug hunting. Exploratory testing or in-person testing, testing as ensemble testing, and other words we have there. But the idea here is that testers put themselves into a persona, into the end user's shoes, and from that viewpoint, typically manually, learning about the system and designing the next step, what to test next, and going and searching for problems. Now, bug hunting here is not actually just the concept of hunting bug. Bug hunting, in my case, is an event, an event, a bigger exploratory testing event done together by multiple team members, which is actually on one hand a very good educational session, but also on the other hand, very good possibility to pair with testers and business, testers with coders, and also to find bugs. It's like a hackathon event. We have run that in my past a lot, and it was very funny. Now, when we talk about continuous testing, of course, it's not only functional test. It's also continuous non-functional testing. So if we talk about keyword-driven test automation, and especially what testers need to learn, I would say that it's extremely important, or let's put it that way, I found it very good to learn Robot Framework because it's an open source tool, because there's a very large community around it. This January, I was on the Robot Framework RoboCon conference here in Helsinki, and they said there are 30,000 people on the Slack of Robot Framework. 30,000 people is really a large community using a test automation framework. And you will find a lot of open source libraries that can help you with solving very many different problems. So if you want to learn test automation, go start maybe with Robot Framework. Now, as I mentioned, exploratory testing and bug hunting is also important, and I see that as always my English, complementing technique on top of specification-based testing. When we talk about specification-based testing, for example, looking into the acceptance criteria, acceptance test, looking into more detailed, maybe written specification, that is like usually the positive scenarios, right? And when what we want to add as well on top of that is the negative scenarios, the alternatives, the failure modes, what could go wrong, and check and test for those as well. Exploratory testing and bug hunting is focusing much more on this area, I would say, and this is what I have seen. This is how we used it many times. And the acceptance tests, so specification based test, design based test cases, are more focusing on the positive scenarios. Now, if I look into the non-functional testing as well, so typically we talk about the ilities here, right? Testability, reliability, performance, ility, capacity, ility. But anyway, the idea is that these are like quality characteristics, abstract qualities that is telling you that the software is good. Many times these are connected to feelings, actually. When we talk about continuous non-functional tests in DevOps, I believe our testers need to understand a new ility, and this is observability, that needs to be tested as well. So we use observability to see if our tests are running, but we also need to test the observability features. And we need to test the telemetry features. So all these are important, and you should not forget to make sure that these functionalities are working as well. So now let's move a bit to the left. What type of things we have here? So first of all, this is like the normal shift left, right? CI/CD practices, CI practices, most importantly, continuous integration practices built on unit testing, maybe with TDD, so test-driven development practice, a lot of automated testing. Also, you can and should learn about code analysis, the different lint tools, the different static code analysis tools. And very specifically, because DevOps is so careful, DevSecOps with security, you need to look into static application security testing solutions. So, how to learn CI/CD? One of the techniques we have is actually, I'm showing as well to you the original version of the pipeline game. This is what was developed originally by Emily Betch. And this is really a card game that your teams could use to learn about CI/CD design and how testing is actually part of the design. You see a link as well in the middle, pipelinegame.ficode.com. You can play actually the game online with your teams in a digital format as well. It's good for education. I'm running these sessions on conferences around the world, and I got really good feedback. And then also Emily is running these sessions, and many of my colleagues are running these sessions with educating basic rules of CI/CD, and then giving the teams a very easy to use interactive session with that. The other area or other input which helped me to understand more CI/CD, because I believe every tester has to understand CI/CD practices, is, for example, from the GoCD pages through the blogs and articles they have. Now, looking into the static code analysis area, and seems that I missed to update the title here, sorry for that. But Snook, for example, or SonarQube are also very good tools to make sure that you look into code vulnerabilities, security vulnerabilities, as well as compliancy problems or code guidelines problems when you are not keeping the coding guidelines. So these are also very important tools, and I believe testers should again learn these, because these will help their work as well. They need to work together with the developers in the teams to make sure that these are in place. Now, moving a bit to the right, in DevOps, what are the next steps that are helping on quality? First of all, we need to make sure that we do acceptance testing on standardized staging environment. When I say staging, this is production-like environment. Production-like, where the like is as close to production as possible. Now, if we are in the automotive industry, we go through these hardware in the loops, software in the loop, model in the loop, software in the loop, hardware in the loop stages. Hardware is extremely expensive. It could be very difficult. It could be coming very late in the project itself. So these are areas that you need to be careful with. And when we say production-like environment, spinning up a Docker container or a Kubernetes cluster is easy. But when we talk about testing with hardware, it might not be that easy. Still, we need to try and go and cloudify our resources. Even if it's a hardware, we need to make sure that that hardware is accessible from far away, from remotely. It can be triggered and tests can be run on it through CI/CD pipeline in a managed and standardized way. When we talk about standardization, it's also like how to make sure that you always know exactly what your test environment is. How does it look like? So how the system and the test looks like, how is it configured? And the best approach for that is really to use the DevOps practices, the on-demand practices. So you spin up the environment when you need it, you make sure your configuration is done by infrastructure as code practices, and then after usage, you just delete it. First of all, not to use cloud resources that you don't need, not to pay for them, and not let the environment pay for it, but also to make sure that you always have a stable, known state of your environment from where you start from. Acceptance testing on standardized staging. So acceptance testing is, again, running those positive scenarios, mainly your acceptance tests, again, that are hopefully already automated in keyword-driven test cases. Now, another point here for reliability, you remember the fifth DORA metric that was not actually on the picture, is reliability, to make sure that our systems are reliable. Now, how can you make sure a system is reliable when you don't own the hardware, you don't own the cloud itself, right? Cloud is not 100% reliable. This is to all the time making sure that you inject different faults and you check through how the system behaves. I will go into that deeper a bit. And also, the other aspect is here, the other aspect here is different deployment strategies. I will get back to that, canary release and dark launch, just in a second. So when we talk about chaos engineering, what does it mean? Chaos engineering is a practice maybe best known from the Netflix Chaos Monkey or the Simian Army, which is a set of actually robots that are causing trouble, right? Little monkeys are running around and they are unplugging virtual resources. Back in my early tester age, we did a lot of this kind of monkey type testing. When we went down, one of our colleagues was running tests and the other one was actually killing processes, physically disconnecting cables from routers, or just switching off the electricity. And we checked how the system behaves. I worked with very highly available systems, 5.9 availability, which means 5 minutes downtime per year. And they had to really handle these situations. So now the Simian army, or with VMware, the Mongol, or from Amazon, the AWS Fault Injection Simulator, are actually tools to simulate different infrastructure, Kubernetes, container, Docker, whatever levels, networking levels of problems, noise, network noise, jitter, other type of problems. So it's a really good technique that you run your tests, and under that you create chaos and you measure how the systems work. Now, when we talk about deployment strategies, this is now not testing. However, this is fully quality assurance. In case of a deployment strategy, what we try to do is actually minimizing the impact of a failure if we have a failure. So with, for example, the blue-green deployment strategy, we have our new version of the code on a set of new machines. These could be servers or actually virtual resources. And when all of that is installed, with the help of the load balancer, we just switch the traffic to the new server. If there's a problem, if we have an outage, if any of the users see there's a problem or their service is not maintained, then we can easily switch back to the original version. Typically, after deployment, we wait some time using observability and telemetry, monitoring the systems and understanding if everything is fine. If yes, then we use again now the blue systems to develop or actually deploy the next version. This is actually your staging environment now. So again, like you see, staging and acceptance testing, staging is coming together with the different deployment strategies. How is this helping with quality? As I mentioned, we are reducing not the probability of a failure. Testing is reducing probability of failure. And the blue-green deployment is reducing the impact of a failure. All right. Also, if we talk about canary deployment, which is another one, it's a different. I would say it's type of a blue-green deployment, but here only a few of the end users are actually seeing the new version of the software. So, for example, only 1% of our end users are running the new version, seeing the new version. And then we are able to decide if we want to get to 10%, 20%, and slowly we get everyone to the new version. In case of a problem, again, we can just roll back to the previous version. And dark launch is another technique where we actually have both of the system running at the same time, but from the new software, we are just stopping the responses. We measure it. We can measure performance, for example, but we are not letting the end user to see the responses. So this is also very important, I would say. Very important quality technique, practice, the testers should know about, and they should work together with the ops guys now to make sure that these are all in place. Ops. So now we were moving to the left, moving to the right. Let's move to the far left, focusing on customer-centric quality assurance. And as I said, it's important that we understand actually what the customer wants, because maybe our solution is technically super correct, but it is not solving the problem. It's not, validated. So testers should need actually to understand design thinking. And that's what I learned, that it's really great to understand design thinking, understand how the different user personas are identified, what's the empathy map, what do they hear, what do they feel, and then what's the customer journey. So how the end user actually goes through our service, how they are using, how they get to start using the service, is what they do after using the service. For example, when I buy a Lego, it's not starting just by opening the box. There's a lot of services before that, right? That's my customer journey. It's the buying journey as well. And even after that, what do I do? Do I rebuild this little guy here, or do I play more, or do I start collecting? Yes, I did. When we see personas, customer journey maps, and testers understand that, they can, for example, define end-to-end test cases, really these high-level business process test cases based on the customer journey maps. They could also support product owners to do backlog management, backlog refinement, to slice the work into stories through the story mapping technique, utilizing BDD, behavior-driven development, or acceptance test-driven development, to actually define tests to represent the requirements. And also, if you think about the customers, as I said in the beginning, design feedback through prototypes. So, for example, a UX prototype with Figma tool, a wireframe where we have already the buttons supporting the customer journey, but no code under it. Those could be also very good techniques to have testing in place and to get feedback on the quality. So these are also areas where I believe testers should go. Now, if we look into the BDD area, like how we get from insight to specification, you see there's a flow here. So from insight, from customer journey, we discover the different problems the customer have. Then we define what's the best problems to be solved, what needs we want to answer. We define user stories for them. And then again, how to solve it, what's the best way to solve it. You go around that, and with your team, with backlog refinement, using, for example, Gherkin scenarios, given when then scenarios, to define acceptance criteria, which are validatable. And now I go back to keyword-driven test automation. With the Gherkin in place, with keyword-driven test automation in place, you can immediately combine these and have an executable, validated specification at your hand. This drives your continuous testing, which could be then again run on staging, right? Standardized staging environment. All things connected. But for using these, testers needs to know, for example, the BDD technique, the behavior-driven development, where I can also show a few books, right, from Gáspár Nagy, friend of mine from Hungary, and Seb Rose, writing the first two books of first two BDD books, Discovery and Formulation. They are working on the third one, which is automation. So how to actually translate from the Gherkin scenario into automated scripts. Now let's look into the last part, which is then really shifting right into live, quality assurance in live. So first of all, it's extremely important that we have telemetry and telemetry in place, understanding if anything went wrong. You remember with blue-green, we deploy the new version, but needs to make sure that we are measuring our system's behavior. And in case of a problem, we can roll back or fix quickly and roll forward. This is, I would say, telemetry is the technical measurement of quality. But then we go into observability, which is more like understanding how the end users are using it. If we have proper observability, for example, we could do A/B testing, which is to see that which solution of the same problem, which feature that we developed for the same problem is working actually better. If you want, for example, more users to use a service, like you want them to pay with a new payment method, you can test with A/B testing that which type of screen or which type of anything else is helping them to test, better, to use that solution better. Now, On top of observability, it's also very good to go out to social media and monitor actually how your systems are being used. So for example, just checking also the App Store or the Google Play on how many stars you got, right? What was the feedback on your application? Many times, and this is what I've seen when Spotify was presenting their quality processes, they have giant screens in their development area that is showing all the negative comments, all the one-star comments on their application, area from area, like physical geographical locations based. So they know immediately if they deployed something wrong or if there's something broken in an area. The last one here is ITSM, so IT service management. You have a service desk. Those people are listening to your end users, and you can utilize a lot of that information to improve your quality. And of course, in case of an incident, also running blameless postmortem to understand the root causes, not to blame somebody, but to understand what went wrong and how you can improve. All these, again, are important knowledge for testers to understand. So if you look into telemetry, I have Datadog here or Grafana as some of the examples for telemetry, and also on status page, which you can see a fresh picture. I just captured this today, showing that, for example, this intercom messenger had some kind of issue in the last 90 days. You can see real-time data of what went wrong. If you would click on it, it would show immediately even deeper telemetry data. A/B testing, as I mentioned, you can have like different variations of your solution and just checking conversion rate, for example, and deciding which one you keep. So now we went to the left, to the right. We understood all the different areas for testing. But as a tester, you can also support quality, and quality as a quality assistant, built-in quality practices and mindset throughout the whole organization. For example, what you need balanced quality goals. You need to understand where to focus more. You need to learn how to create your quality assurance, and here I say continuous quality assurance strategy implemented within and around your pipeline. And you also actually need to support and work with your colleagues to create the internal developer platform, which is supporting a lot your organization with having its effective and efficient way of software development on a highly maintained DevOps platform. If you look into balanced quality goals, you can use, for example, the risk storming game to work with the different stakeholders and ask them that which quality aspects are the most important for them. So giving really a good understanding of quality needs in the whole organization. If you are interested in internal developer platforms, I really suggest you listen to our podcast, the DevOps Sauna, the Sauna from Finland, where my colleagues are talking and discussing a lot about platform engineering, how to start with it and what are the pitfalls, and a lot of other topics on security and others. So with that one, I want to ask you, after going through all these, that did you identify anything new for yourself that you would start learning from tomorrow? Anything in the getting back to Mentimeter? So anything that you would say that based on now this flow and the different aspects of testing in DevOps, you identified something that you would like to learn more? So while you are answering that, let me go into the takeaways already. So when we look into quality transformation in organizations, how do we see that typically? So usually what we have, there is a big focus on detective quality assurance. Detective quality assurance, where the aim is to capture faults, the aim is to find something with using automated tests and best practices like shared test repositories and reporting standards. Most of the companies are still here. I would say the larger ones. Many times, of course, the cloud native butterflies, the web people are already in the DevOps, but many times larger companies need support to start and going where they want to be, to shift left, to have more proactive quality assurance in place. So to understand what to do when you design, what to do when you code, even when you use AI-driven development to avoid human errors. And then also to understand how to go to the right when releasing and when deploying into production. This requires the pipeline in place. This requires the proper flow, which actually requires the, as I name it, 3-pillar balanced quality model to have in place. So if I need to, summarize all my talk in one slide, this would be the one slider. If you want to share or take one slide only, this is the slide I suggest you take. As you see, it starts with the balanced quality goals that all the organization is aligned on that. It utilizes the internal development platform to have a CQA strategy implemented on your CI/CD pipeline, and having all these activities and practices shifting left, proactive quality assurance, and also shifting right, reactive quality assurance in place on top of detective quality assurance. All right. Yes. Quick takeaway before we look into the Metimeter again. So I would say quality assurance definitely has a role in all the 3 ways of DevOps. So it's not something that is not needed anymore in DevOps. However, you need to learn a lot of new technology and the new methodologies, new practices. There's a lot more on the left and there's a lot more onto the right as well. But keep in mind, testing is never, ever boring, especially if you work in a DevOps organization. So with that, let's see if we got any responses here in the Mentimeter. Not really. I'm not happy about that, but that's life. All right, and with that, I think I just forgot to add my thank you slide to the last. I was so occupied with the Mentimeter, but anyway, I'm now happy to have some of the questions from you, if there are any questions. Thank you very much for listening. Paul?
Szilard, thank you very much. We've got a couple of like 4 minutes. As you said, we didn't have a lot of questions. I was really trying to encourage everyone who's watching to ask questions. I see Stanisha said thank you. Very helpful over there. Great, thank you.
Thank you.
I wanted to go back and talk a little bit about 2 of the things that you had up there. One was you mentioned the chaos engineering, I think.
Yep.
And in fact, I love that slide too. You mentioned take a screenshot of that because that is fantastic. I may steal it, but I'll always give credit to whoever who puts it together. So you'll always get your name on that. That is a fantastic one. I've always kind of curious about chaos engineering, fault injection, and stuff like that. Can you tell me, in your experience, what have you've gotten out of that, actually trying to break the system or have the system be a little more flaky on that?
Mm-hmm. So one of the, I would say the most brutal fault was what we captured is when we started moving, and that was quite a few years back, but we started to moving to the cloud with our development, being cloud native. And there was the first rise with containerized telco applications. And someone just logged into the container and started to do some kind of hacking and chaos things there. And you expected that, okay, maybe the container itself dies, maybe then the whole Kubernetes layer will spin it up again and something like that. But actually what happened, we got the Linux panic alarm or whatever. So it actually crashed the underlying operating system, and the whole server got restarted from a container through all the layers. And that was a bug hunting event when we testers were together with architects, and they were like scratching their heads like, oh my god, so now let's go back to the drawing table and figure out what thing went wrong. So that was one of my favorite findings there, that when we used bug hunting, exploratory testing, and chaos engineering together.
I don't think I've ever gone deep into trying to intentionally put in bugs into my systems. Mostly, I've always been, as an automation engineer, praying the system is as stable as possible. But it does remind me of one situation I've mentioned on this show before, where I had the engineers tell me that the system does not come up to a ready state, and they asked me to try and automate the system, shutting it down and bringing it back up again. And I initially said, well, that's kind of impossible. I can certainly write a script to shut it down, but I don't know how we could get it to come back up again unless we build a robot to hit the power button. But as it turned out, in that situation, and this was my first automation project, we actually had a little robot that would do that exactly. It was a universal power supply, and it had built into it that it could detect if the system was offline. It would actually send a wake on LAN command to our systems and then power it back up. And we actually figured out every 63rd reboot, it would not come up to a ready state. So it was a pretty cool catch and great thing on our side.
That's not really 5.9 availability.
Yeah, no. Well, it was in the test. It was in the QA lab. But the other half of that, and I do want to get to Gil in just a second here. The other half of that is that they said, well, every 63rd reboot, how often is that going to happen in a lab? And what happened just 4 days later was we installed our lab, and they were training the doctor on how to use the equipment, and he basically flipped the switch on the 63rd reboot, and it didn't come up, and they nearly lost the sale on that. And then I got more credit because, oh, hey, this low-level ticket. Oh, well, actually, it's a showstopper now because it's actually losing us millions of dollars. If you ever get something like that. Yeah, and I tried to convince him, like, hey, why don't you give me 1% of the money I just saved you? I'm like, no, we're not doing that. Here's a coffee and a free meal at the commissary. But, thanks a lot for that. But
I always say that incidents are my friend because that helps me to prove that testing worth it.
Yeah, absolutely. So everybody, while Szilard was actually talking, I went and looked up all those books that he mentioned, the BDD books, Discovery and Formulation. I recommend you guys take a look at that. That is fantastic. And I am going to basically say thank you very much, Szilard. It was a pleasure. You're really entertaining, and the information is fantastic. We'd love to have you back sometime in the future.
Thank you so much, Paul, for the opportunity, and I hope that I did not give you too much information, so you will have a good sleep still. Maybe
you're fine. And I'm going to go research a little bit more on Ethico. It looks like a fantastic company too. All right.
Thank you very much. Have a great
Cheers.
Other meetup as well. And yes, bye-bye.
Bye-bye. All right. So that was Szilard Szell with DevOps and all sorts of information. We have Gil coming up in just a moment. Just wanted to remind you, there was a couple of books he mentioned. Again, I want to mention my book over there, the Enhanced Test Automation with WebDriver IO, if you're into that. I'm going to be putting together a version for other frameworks, much like he mentioned. Frameworks are, it's whatever flavor things that you're happy with. I know he mentioned the robot framework. That's probably going to be the next version of that book I'm going to put together. And also want to mention again, the software testing strategies. This is by Matthew Huser. Get his name right. I want to try that. Also, really good information on there. So check these two out. It can be on ebook, or you can also order it physically. I like writing notes in my books when I do that. So coming up next, we have Gil over here. And let's see if we can get Gil's picture out there. I see Gil. He's coming up. Hi, Gil. How you doing?
Great. How are you?
I am doing great. I understand it is extremely hot where you're at.
Not enough. I have some tea here to make it really hot. But yeah.
Ah, cool. If it gets too hot, I got this USB fan that I put in there. It's got some advertising from my former employer, but okay. So Gil, I am looking forward to this, and we also have a couple of. I had a couple people saying they're excited to see your presentation coming up over here. So without tell me a little bit where are you located at, and tell us a little bit about what you do, and then we'll let you get started.
So I'm located in Israel, where it's currently very, 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 very hot. I'm a trainer. I'm a consultant. I have a full slide on that saying my name on all things software and testing and stuff like that. And today we're going to talk about something that is very related to that, testing web applications.
Excellent. I'm always into that. I've been doing that. I've been testing web applications for 24 years now, and I still have not gotten bored of it. So, Gil, if you share your screen, I'm going to turn it all over to you. And if there's anything I can find, any links or stuff, I'll be posting them. Everybody, remember, you can add questions to ask of Gil live. It's you can do it either from our LinkedIn event channel over there, or if you happen to end up over on the YouTube channel, you can do it from there. And with that, Gil, take it away.
Okay. So, hi, I'm Gil. I'm one of these guys, really. But you'll have to at least guess because I'm being masked there. So we're going to talk about aspects of web testing. Web testing, also that is doing this for like 20 years. I haven't been doing much of that. I've mostly been a backend guy and APIs and stuff like that. And so it was like I knew about Selenium and didn't touch it that much. But over the last couple of years, I've been more into that. And what I'm going to talk about today is, it's not even what is web testing, because everybody knows what it is. But I think that when we're talking about, we're saying web testing, everybody means something else. So I'm going to cover a lot of that. So yeah, lots of Spider-Man going to be around here, except maybe me. So like I said, I'm a trainer and consultant. I work with people, developers, testers, automators, wherever they are, regarding anything that makes software better. Everything around quality, testing, developer testing, web testing, that too. So if you want to see anything about my services and stuff like that, go to testingguild.com. There's also a YouTube channel when I do all kinds of webinars, and you'll find recordings there and short videos. That's enough promotion. Okay, so I'm going to show you my demo application for today, and we're going to discuss this in all kinds of aspects. So what you see here is Visual Studio Code. If you haven't met, thanks Microsoft for that. This is the application. It runs locally right now. It's a registration application. Basically, you have like 3 fields here and 2 checkboxes. And when it comes up, it comes like with 3 empty boxes. This one checked. I want to get promotions too. And this one is not checked. And you can't really press the register button. Click on that. It will enable that. Unclick or re-click, disable the button. If you try to register, if there's an error here, like everything's either missing or the email's doesn't look like an email, you get a nice error here. But if you try to actually do something that does work, like this, with .com at the end, because it needs to work. And you do this, you get a thank you page. Like I said, a registration application. Go back to the slides, and the answer is, when you're thinking about it, does it really work? Because we kind of jump into all kinds of automation stuff like that. This is like a registration application. It should save my data. If I look at the page, what kind of, on the screen, what kind of things, apart from all the test cases that are, we'll talk about them, but the main thing here is that did it save the data? Now, there are clues there. The thank you page tells me my name, which is nice. But that's one aspect. I want to see that it actually works to save the data. I showed you something that when I clicked the register button, when everything was empty, I got the error thing. And one of the things that we need to think about when we're testing is we expect that if there was an error, nothing was saved, right? But maybe it was. So when we're talking about testing scenarios, we'll jump to automation later. Still thinking about testing options here. What really works is something that we need to define for ourselves. What is important here, and we can. Some of the things we can see on the screen, and some of the things we can't. So when we talk about web testing, and we're just thinking about clicking buttons and checking messages on the screen, it's not everything. So we probably want to keep that in mind when we're doing it. So a bit more about this application. I told you this is like, I'll show you the code in a minute. It's a Next.js application, front end with React, back end Node. Regular thing, the database runs locally. It's a JSON database. It saves the data in the JSON format. Let me show you the code a bit, how it looks like. What you see, let me go back to my main page here. So this is like the main page. This is its code, lots of events here. The whole thing here is a React component called registration. What else do I have? I can show you the thank you page is here. Thank you page is here. This is the code. If you can look at the code, by the way, you'll see that if I'm sending the name that you saw, Gil, just before that, as a query parameter, so it shows that. But there's another case that I didn't show you, that if you go to the thank you page, and without the name, you'll get something else. And this is another case that I'd like to check that it actually works. So this kind of starting to tell us a few things that if we just look at a web application like a black box, all we see on the screen is everything that we see on the screen. But I gave you a bit more information. I gave you about the division of where the code sits. I told you about the React component, which we're going to talk about a bit more later. And I told you about the database study. This is a file database. This is where it saves the data. All you see here is automated tests results, but it doesn't matter. So if you wanted to test manually, by the way, you'll go to the database and see that the new information is there, right? Think about automation, we'll try to see something else. What else did not mention is when you go back to the registration, when you do the register here, what happens is that it calls an API. The API is register, sends all the data that you've seen, that it gets saved into this JSON database. That's basically it. The error that appears here, all the interaction is part of the React component. And the only thing on the page is the heading here and sending the data through the API. So the React component doesn't save the data itself. It's interesting because we talk about that too. OK, so I give you a bit more of information about that. And now we can talk about, OK, so we talk about different test cases. But with this kind of information, we know how the thing works, what it's built on, how the database looks like. The thing that it actually resides on my computer here, not somewhere in the cloud. We can think about a test plan. Now, when we're saying test plan, we're actually thinking about the list of cases and how we're going to test it. Let's separate those. The first thing that we're actually thinking about is what we're going to test. And this is our test plan. So that test plan basically is a list of test cases, hopefully prioritized by what is important. Then when we have this kind of list, we can talk about how are we going to to test these cases. And that part is the test design. We can decide that we're going to test everything through, I'm using Playwright today, so everything through Playwright. Or maybe we can write other tests. Maybe, let's look at the database, for example, or the locality of things. Everything is here on my computer. And therefore, if I showed you like this architecture, and this is all I told you about my application. It's a client-server application with a database, and without the tidbit that everything runs locally here, you'll say, well, some of the cases that I need to check that are working, or working as expected, is a connection to the database or timing issues, concurrency, stuff like that. Everything that we think about, like multiple users scenario. But once I tell you that everything runs on my computer, there's not going to be a disconnect. There's probably not going to be any timeouts. Setting up a test that checks what happens for timeouts, it becomes even more complex than in regular application, but let's keep that. So knowing how things are built, how things work, gives us an idea in terms of how we're going to test them. If there was, for example, if everything was running on separate machines, I would probably need to do things like with the data. For each test, automated test, I probably need to reset the data, load the data prior to the test, things like that. This falls into the test design part. So once we decided to say, these are the things that we're going to go through, we need to think how we're going to test them. And if I'm calling another API, I'll need to take care of it somehow. I'll either need to set up the server to give me an answer when the test runs, or I need to mock it, but this is going to be part of the design of the test. So we have a plan, different cases that we'll go through in a minute. And then we have to say, what kind of test do we need? Some of them are going to be unit tests. Some of them are going to be component tests, as we're going to see. Some of them are going to be like web test. This is what we thought about when we started this session, the image that we have in our mind. So everyone has seen this kind of sort of pyramid before, I'm guessing. This is not coming with spiders, unfortunately, or Spider-Men, or Spider-Women, unfortunately, only with tests. A few words about this, though, even though everybody knows about test pyramid. This is a pyramid, its shape, because of cost. Unit tests are easier to run, cheaper to run, faster to run, cheaper to set up, than all things on the top. It's not a pyramid of value. This is important because even if I had like a million of unit tests and none of the UI stuff that goes end to end, we probably wouldn't be that confident in releasing it. It's cheaper to have these little tests, and in the long run, I believe that it actually works in your favor to have them, but this is a cost pyramid. There's another thing that we don't talk about, but kind of relates to this kind of pyramid, is the isolation level. And in unit test, obviously, what we're testing, like pieces of code, that means that when we're testing something, it doesn't talk to the outside world, and therefore we don't need to set up all these services or mock services. And if we do, it's going to be a bit more expensive than setting up a mock for function. And one more thing about the UI part. We kind of think about UI as an end-to-end thing, but it doesn't really have to be. It has to be. It can be like end-to-end, or it can be front-end to back-end to mocked service, or a mock database. It could be all kinds of options that we can select, but we put them in the bucket of UI. So this is more about communication. We're talking about people talking about, yeah, we have an UI test or web test. It may not mean what you think they mean. Unit test kind of, everybody sort of understands the limits, the boundaries of that. Okay, so yeah, that's good. So what we're going to do is, I'm going to basically, I'm going to talk about something that is going to help me test better. So I talked about test plan and test design. Test design is how I'm going to test. So what is test better? Turns out, and we throw this term around very loosely, there's something called testability. Now, we usually think about testability as like an inherent attribute of the code or the system. And that's not true. We can write code that is more testable than other. Usually testability is not an on-off thing. Everything's testable depending on how much time you've got, the tools that you have, and most important, the motivation that you have to test it, or your boss's motivation. So everything's going to be testable, but going back to the pyramid, it's going to cost us. Now, I actually structured the code in a certain way to help me test it. Let me show you that. So there's this error that appears here. I told you that it's part of the React component, which it is. However, the validation bit, this is it. The validation bit, it sits here. So this code, the validation, which checks that everything is not empty and the email looks like an email, that's the regular expression here, I put it in a separate class. Now, I could have put it inside the React component here, the registration, but then I will have to test things together. And that's not a big problem, but it's going to be slower, and it's going to probably need to set up things that I didn't need to. I could test validation through the UI, the playwright test. Again, everything. But again, it's going to be slower. It's going to be expensive. Maybe fall or fail on things that I didn't expect because I want to concentrate on this. So moving code around, refactoring, actually helps me gives me options. I can select to unit test this thing rather than run through this component. Another choice that I did in terms of testability is that my choice again, that this component, as I told you, does all the user level interaction, and it interacts with the containing page. When you do the register, it sends an event. Where is that? Yeah. right here, sets the event to the page with the details and the promotions, but it doesn't call the API by itself. If you want to do that, to see that, you'll have to look at the page itself, which does the submit here, calling the API, the register API, to save the data. Where does the code of the API sit, or calling the API? It could sit in the component, it could sit in the page, but by selecting where it's going to be, I gave myself options. Now I can do like a component test for the React component, which is cheaper than checking the entire page. Cheaper in time, stuff like that. With that, the things that we didn't talk about. So we can, by deciding how to design our code, really impact the stability. And it's not like we're closing doors. It's more like opening them. We're giving ourselves, as developers or as testers, it doesn't matter, working together at the same team, options of how to test things. So again, going back to the web testing stuff, it does have different levels of things. So yeah, let's just talk about what is the web testing that we have in our mind, the thing that we do with Playwright or Selenium, and how it's different than component testing, just to get everyone on the level. So web testing is, well, which one? I have the component first. So okay, so my example is in React, but everything that you're using today to write web code really is componentized. It could be React, it could be like Angular, whatever framework that you're using. And this is a kind of a new idea in web, like of the last few years in software. Componentizing things have been around from the 80s. Whenever we had the first class, that meant something. And there's a reason we like doing components. It makes sense in terms of code. Code that handles things sits in one place. But it's more about the isolation. Now, how does this thing work? We have a test framework. In my case, I'm using vtest. You can use whatever test framework that you want. And our component is something that renders itself into HTML and JavaScript, obviously. But it is only there in build time. Once you pass build time in production, you won't see that component in the code. So the idea is that we take this component that really translates into partial HTML, and we need to give it a container, otherwise it won't render. So when we're testing this, we're kind of testing inside something that we call a test bed. Now, in Angular testing, it actually is called a test bed, but it's mainly a container. And this container does two things. It renders the HTML and JavaScript for this component that we're giving it, and isolates this component from everything in the world. So imagine that you have like a whole page with all kinds of things on it, and you want to test one component that's on it. In regular web application, that you need to load everything, set up everything for all these things to load just to get to your component. In component testing, we're kind of squishing everything to focusing just on our component. And we need to supply whatever the component needs. Now, my component doesn't need anything. But if it were talking to an API, I will need to supply whatever it requires in terms of mocking or real behavior. So this is how component testing works. I'm going to show you examples in React testing library. This is how web test that we have in our mind works. It's a lot heavier. Machinery is a lot heavier because we have a test framework. I'm using Playwright. But if you wrote things with Selenium, for example, you'll have a test runner that operates Selenium, because Selenium is really running drivers which talk to browsers, which then load the HTML and JavaScript, and you don't know what happens on the back end, because that's like complete mystery. It's also true for the component if it talks to other things, but if it doesn't, the whole world becomes the component, which becomes easier to test. So when we're talking about web tests, it could be like a combination of or options of all things that happens behind the server, but you need a whole application, a whole page to load. Otherwise, nothing will be loaded that you can operate on. Different frameworks work in different ways, but all of them have this kind of structure, which, like I said, suffers, or and then let's talk about the suffering first. It is complex. It can fail on different connection points. It is heavy. It is slow. You actually feel the slowness. It's not like if you run the component test that I have with the unit test, you won't see any difference. Although a rendering takes place, here you do. So that goes back to the pyramid. We need to understand the cost of different things. But like I said before, what we consider a web test really can go in different ways depending on what the server looks like. And if we're just talking about scale, a web application is a lot bigger than a web component, and therefore probably in most cases will require a bigger setup. Bigger setup means it just becomes more expensive, slower, can fail on different points. So yeah, if we can do things in component level rather than on page level, that would be great. But remember, we don't get the same value from smaller tests. We don't get the same confidence from smaller tests. So we need to balance things out. So we have an idea of what web tests and component tests are. Let's take a look at what I did. And it's not like this is how you should do it. This is how I did it. But there is some kind of logic behind it. We'll talk about that at the end. So for the validation part, let's look at the validator. Just JavaScript or TypeScript can run anywhere, doesn't have any dependencies. So obviously a unit test will help here. I wrote a couple of them for validation. Some of them, the cool thing about the unit test though, is that I can check. This is what the component call, or the page calls. No, the component before it sends the event. So this is a primary function. It checks that every field is empty. Let me squeeze this here. You already know about this. So everything is not empty, and the email is not invalid. And if there's an error, it will throw an error, and we want to check that in the tests. So a couple of tests that I can check. Is empty. I can throw different types of cases on it and see what the result is. Same thing for email validation to see all kinds of things. And before I move forward, each one of these cases that I can write in a single test here, if I did it through the web app in Playwright, this would require starting over all the time or continuing from something, which will create not so clear tests, stuff like that. So there's a good reason for me to structure the code like that, and then the test reflect that I can test just those small things. So these two, the final two check that if all valid information is passed, everything's OK, no exceptions thrown, no errors thrown. This is how you do it with a try catch here. If everything's OK, Excellent. There's no failure. Otherwise, if there was an error, that's a failure because we didn't expect it. And finally, that something throws. So like small tests, unit test, excellent. Now let's talk about the component here. We're moving to the component level. Remember, the component doesn't save the data. It does say invoke an event when I'm clicking the register if everything's valid. So what kind of things can I check there? All kinds of behavior. I decided to split that into two things. The first one is a startup. What happens on a startup? I'm sorry for the squiggly lines. It's a TypeScript things. I assure you everything is run. I actually ran them before we started. So how does it work? Render is part of React testing library. It does exactly what you need. You give it some kind of React code, JSX code, and the component. It will render itself. And you have to pass, by my design, something that will get invoked when it's ready to invoke. But first of all, I split it into startup and actual behavior. Why? Test organization is very important. It makes sense to see what kind of things we're testing together and how to separate other stuff. And also makes sense in terms of where will I put the next test that I will try to add. So splitting test makes them a lot more readable and helps us make sense of the system. So on startup, I'm expecting the first, last name, and email to be empty. This is like, if you've seen Playwright or Selenium, it can look similar in terms of what it gives you. Basically, I'm checking that everything is empty here. Checkboxes are checked correctly. And on startup, I'm expecting this one to be checked, this one not to be checked. This is not to be checked. And the register button is disabled, obviously. So yeah, I can check that on the Playwright level, which I'll show you some of them. But I don't have to check everything there. Again, this requires more time or running time. I'd rather do it where it's possible, it's nearer to where I want, and easier to debug also. Because these things I can debug, and they are running in process, both unit test and component test. So I actually can put breakpoint more easily than if I were debugging a whole process from the outside. OK, so these are the startup things. The behavior things, let's look at those. So this is a bit more complex because we're trying to get all kinds of behaviors here. Should enable the register button after checking the terms checkbox. This one. And should disable the register after unchecking it, which you just saw. Interesting thing here. Think about. Notice that I just show you exactly what it needs to be disabled, right? I clicked this, and then I re-clicked it again, which made it disabled. You need to know this. And this is something that we have a problem with in component tests. And when we're in web application tests, it even become a lot more complex, connecting ideas to elements on the page. Because the idea, this needs to be disabled because I didn't check the thing. This is like a business requirement. It's not a component requirement. And when we read this test, and sometimes when we read web application test, like the whole page, we'll see these things, and we'll assume that when we're reading this, we'll understand the connection between these elements. It's not always completely true. This is the only, apart from my oral explanation, this is the kind of things that explain the connection. Kind of missed them. So it displays the errors, and this is something that can be very complex if you want to try to check all the cases here. So I'm just, another thing that we need to do in order to check the error, I need to check this thing. So I enable this, and therefore only then I can check for the errors. So this that starts to appear everywhere, I need to check the term box, is part of the tests, but we don't really connect to that when this thing will fail in 3 months, and we will not remember that. So checking that it's there, you can actually check that if it's important, it's going to be like in red. You decide what to test, of course. Hiding the errors, I didn't show you that if you try to do this, and you want to make this go away, you have to type something. This is something else that I want to check. So small behaviors that I can do at the lower level, but this is the lowest level I can do that. So this is getting checked here. And the final thing is that, remember that I said that if everything works, register sends an event to the container that everything is OK. So I need to set these things up and check that it got the message OK, the container, because the page doesn't play here. It's not part of our world. So this is what you'll see, event handlers and mocks and stuff like that. Check that everything was OK. And this, by the way, will not be possible from the web level, because the events will look completely different. Like I said, components are there at built-in, not at runtime. So scripts will look differently. Events will not be easier to comprehend. Things will happen that the React does for me. So I can do things and check these things at a different level if I thought about it. So these are my component tests. If I look at my web tests, like I said, Playwright. So first of all, let's talk about the thank you page. Remember, I told you that it is past the query parameter and shows a thank you, Gil, if it got it, and who are you if you didn't. So I can check those as well. This kind of behavior, it's not a unit test, because I test it with the whole page. It navigates to the thank you page, sometimes with a parameter, sometimes without. But I don't need to go through the entire registration page. So I need to think about what do I need to check and how I do that. And once I decided, well, this is part of the page, there's no component here, I need to do it through Playwright or my web tests. But I don't need to go through the entire registration process just to check that the thank you page works. I can do this at the thank you page level. So this is, if you think about it, like going down our pyramid level, it's still a UI test, but it's a smaller piece. Now, I have redundancy, really, because if this one fails and the whole registration part works, I know there's something in between that happens. OK, so these are the thank you page. I have the registration spec here, which checks that the registration page opens correctly. Note that some of those things are already done at the component level. Nobody assures me that the way the component loads is the way that the page loads. I wrote both, so I know it does. So I can do this. I put everything in a common here, finding all the locators so you can actually read the test, and you can read them too. I actually did a whole webinar recently about clean tests, clean web tests. You can actually check that on my YouTube channel, and you can actually read that and understand a bit more. But this one goes to the registration page. Make sure the title is visible, the promotion checkbox is checked, and the button is disabled. Why is that? Well, some of them are already checked, but these are really I translated my requirements for the application, the business level application. What are the business rules that I want to make sure that at least are there? I want a title, which was not tested as a component. And in terms of this content, I want to make sure that it loads up with, I want to get the promotions, and I can't really register without it. That's like a subset of the things that I A, tested at the component level, and B, some of them was not at the component level. I want to make sure that it actually works. I decided to write a test because for the error, and I can balance that with the component level. So this looks that checks for the error message to be there if an error appears. And finally, there's the registration process, the full registration, which navigates, checks the checkbox, fills in the data fields, clicks the button, and then makes sure that after the thank you page loads, the thank you Gil is displayed. And then we go back to our question from before: does it really work? Because, like we said before, does it really work requires us to say what is important for us, and therefore I need to define that the data was saved. Now, I showed you the API before. There's a register API that saves the data to the database. If it was the only thing that was available, we'll be kind of in a conundrum, because we wanted to check that the data is there. I showed you the data. We actually went into the database, the file. I know it wasn't that complex. It wasn't like Indiana Jones thing. But we looked at the data, and we can check that it is OK. Sometimes we don't have access to the data. In my case, I actually set up one more thing so I can test it. So I created an all database, an all API, sorry, that my test can call. So this one, basically, if you look at the code, it just brings everything that's in the database. And my more robust tests does all the things that appeared in the UI test before, but then it calls the API all data, gets the JSON, looks for the last entry, and sees if it's the same thing that we entered. Correlates to the operations that we did here. And this is a more complete test. But now our web test includes also calling APIs. And if there wasn't an API, we'll need to find some way to make sure that what is important for us not only appears on the screen, but the data is actually there. So it's data, it's state changes, whatever it is. Even if it's not on the screen, we want some access to that. And web tests do include that as well. So what is web testing? And the answer is very simple, but very big. Web testing is really testing, but it comes in the context of web applications. Think about all the things that we went through. And we went through a lot of things here. We talked about, first of all, the tools. Yeah, we can't get away with them. We all have all kinds of tools. I worked with Playwright and Vitest and Next.js. It doesn't matter. You need to know the tools. So obviously, when we think about web testing, automatically we think about tools. Yes, we need to think about tools. We need to understand tools, what they're used for. Let's put them aside. But let's talk about more things that we did. We talked about planning. What are the cases? What are the cases that are important? We talked about design. What kind of tests for each test case? Why is that work? What stands behind this logic of picking these things? We talked about test design also in the concept of how do I make these tests pass? Because in the beginning, we talked about the importance of what is important in this application. In the end, I showed you how I managed to do that. And this is a design issue, the design of setting up an API so I can read the data, which my test can actually look at the data and say, well, this is OK, this is not OK. So test design is something that is part of testing. Understanding the architecture is something that we do in testing, because we consider things, how things are running, when they're running, what are the dependencies, what needs to set up, everything that, how does it work, is something that we think about in testing. We talked about test organization, where you put things, which kind of tests go together, which tests don't go together. If you've written a few tests like web versus like component or unit, don't put them together because A, isolation, but B, unit tests can run faster, component tests do run faster. If we put them all within one test file, things will run slower. Things will impact each other. This is like a very stupid application, but most applications have dependency within them. We talk about fragile testers because the tests put some kind of dependency between the tests. No, it's inside application. So how we run things really is important for us because we want to run these things. And test organization helps us do this and run only the things that we want when we want them. Obviously, refactoring, moving code around. I showed you the end result of what I did, but it wasn't like that all the time. Helping the ability of refactoring, moving code, not changing functionality. Refactoring is part of what makes testing easier or complex, depending on which side of the force you're coming from. I'm assuming that you want to test easier and cheaper, therefore, you can impact how things get tested. It goes also for debugging. Smaller things obviously are easier to debug and faster to debug. Test maintenance, if you want to explore stuff manually, even partial manually, you have to think about these things. So get me through the login and setting up the account of the 8 pages automatically. I will take it from there. And then I will do things manually. We have to think about these things. Why? Because this is like what we do when we're testing. We think about all these kind of things. So web testing really is all these things. So it is really everything that we do in testing, only with some tools. Some of them are new, some of them are different. And obviously you can take this into mobile testing and stuff like that, but we're not talking about these things today. But there are options. This is what I want you to really, when you come off this talk, really, apart from, I'm going to ask you soon, how many Spider-Man have you seen? But other than that, it's not just automation. It's not just the tool that you're using. It's a whole set of skills that you do every day. And if you're not thinking about these things, I hope that you start thinking about this, because I mentioned the word options and cheap and stuff like that. These are like economic things. It really saves up our time. It saves a lot of despair and debugging time. Because if we take these things and we think about them, and we can apply these options, it will help us. It will help save more time for us, free us for testing other things that we would like to do, rather than reading logs. And that's what I wanted to share with you today. So, Paul, come back.
Yeah.
Questions.
Again, we didn't get a whole lot of questions out there, but there was a couple things that I saw. And I also see Testing and Tooling is chatting with us. And they've been here before, and I always love they ask questions and really give good insights. One of the things I mentioned was while you were doing the live demos, and by the way, I love watching a live demo. I'm a big fan of VS Code. This is the first time I've ever seen the browser actually embedded inside the IDE when you were doing the live. I was wondering, could you show us in VS Code, where is that cool little trick? Maybe it's just something I never came across.
So the application is running in here, one of them. It's already running.
Okay.
And I think you go here to the command palette.
Okay.
And when you do that, you can write simple browser. It's just recently used it, so it's up there. Okay. So if you do that,
that's basically your application name that
you're running. You for the address.
Fantastic.
Voila. And then what I did is like split it.
Fantastic. I have been I've played around. I think my book is on a key here. I'm doing some things. I'm sorry. I played around with JetBrains with their IntelliJ. They have something called Aqua, which is essentially the same thing. It's an IDE, but specifically for test automation engineers. And the trick they do is the same thing. They embed the browser in there. So I love it. I didn't know that I have because I mostly work in VS Code. I do want to give a shout out to JetBrains because I like their IDE as well. See, testing tools, give me a little shout out there. One other question I had is this. This sample website, I always like to go test against sites and sandbox sites. I run one of my own called Candy Mapper. If anybody wants to check that out, have you considered putting this as a public site that you could just go and hit and support it somewhere outside where any of our
the project is on GitHub, so you can actually download and play with it. I can send you
let's jump to the link on GitHub. We'll share that out there.
But it's not like a site. It's like 2 pages, so there's not much to do with it.
Oh.
But people can download the project and.
Can you bring up a browser and navigate to it? By the way, while you're doing that, everybody check out. Gil actually has a site and I believe a book out there called Everyday Unit Testing.
Yeah.
And his website is really easy to hit. It's www.everydayunittesting.com. I don't know how nobody grabbed that site already, but Gil, you're on top of that. That is fantastic. I'm actually looking at it right now, and there's some API information he's got out there, which is something I'm scrubbing up at the moment.
Yeah, if you go to my YouTube channel, which I need to link directly, a bit more easier to get there, you'll see all kinds of webinars. That the next webinar is coming up in 2 weeks, I think, and it's about Playwright in an hour. So if you don't know much about Playwright, so in 2 weeks, the Tuesday, we're going to have a webinar. Like I did one about Postman in an hour. It actually took a bit more than an hour. But
is it paid to get in there, or is that free? We can just sit and watch it.
Registration. You can do this through the site.
Perfect.
And I'm trying to log into GitHub, which is giving me some problem because I need authentication and stuff like that.
Well, if the guys will let me, I'm going to share my screen. I have the, let me do share screen over here. I think I've got it on screen 3, which of course is, no, I don't have it on screen 3. Hold on 1 second over here. I've got it on screen 1. I'm going to share this over here. And you guys can see mirror. We don't want that. This is Gil's site over here, Justin Gil.
So this is, I'm not sure. This is the site, yeah. I'm now sharing the GitHub thing.
Oh, let me turn that off. We'll switch back over to you, Gil.
Yeah, I didn't make it public. It will be public in a few minutes. So it's called a Playwright Intro. It has the whole things that we discussed today, because it.
I'm not sure if you're sharing your screen. I think I stole the share from you.
Stop sharing and then restart sharing. How do you do that?
So I'm always happy to show off stuff that's going on there.
This one, share.
Oh, Julia says, thanks for sharing. I really like that it was practical. Want to challenge the idea of an API for end-to-end testing to make sure that data was stored correctly. Could not this be done at other test level?
Well, it's a very short question. Okay, so assuming that the data that you're interested in is behind an API, okay? Whenever you want to access the API, 2 things need to happen. First of all, someone needs to run this API, okay? And you need to set up the answer that you want for that specific test. So in my case, what I did was the only thing that talking to APIs is the website, and I complemented that with the test itself. It could be like in the React level component, if it actually did that, if the component would actually invoke an API, I could actually do that. So calling the API can be in different levels. It makes sense that you need to set up your both tests and the requests themselves and the data for them at the level that you think that make sense in terms of the test.
Okay. Yeah, well, I do agree with you. I mean, you can do it at different levels, integration level and also an end-to-end highest level from testing. I've always saved unit testing is for the developers. Me as an automation engineer, I'm kind of at just the integration and the unit integration and the end-to-end higher level testing. But this is great information. This is actually the first time I had the chance to sit down and someone give a really in-depth talk about unit testing. And I loved it. We also have another question over here. Gil, do you have a YouTube channel?
I do.
Can you share that link? And again, if you share the screen, and I'll go pick up the link and I'll throw it over here. I did a little search while you were talking over there. Is it Gil Automations? Is that?
Nah, it's not that easy.
Or no? It's not that easy. Okie doke.
I'm trying to take you there.
Sure.
So it's.
By the way, if you want to see some other stuff, I also have a YouTube channel. It is Paul Grossman, the Dark Arts Wizard. I had to put all those words in there just to make it more complex. Yeah, Gil, what's your link there?
It's youtube.com/testinggil. So at testinggil. I'm sharing it right now. I'm not sure if you can see it.
I don't see it on our screen yet. Can I ask our guys in the control booth? Can you see if you can bring up Gil's screen if it's sharing? Let me see if there's any chat going on here. We only do have about a minute or so left, and I do want to make sure the testing and tooling gets your site. Testing and tooling, you guys could also reach out to me or Gil. I'm at I'm at thedarkartswizard@gmail.com if you want to reach out to me and talk to me about test automation. That's make sure it's the Dark Arts Wizard. Dark Arts Wizard at Gmail is somebody else. I don't know what they'll say to you. Let's see. I got it. We have it here. Gil has shared it over here. Thank you, Gil. Testing Gil. Okay.
Yeah.
I'm going to go share my screen real quick, and then we're going to wrap this up. I want to thank everybody and my two guests out here for joining us. Gil, it has been a pleasure to have you out with us. We also had Szilard Szell out there at Ethicode. Oh, by the way, do you work for a company? Any company you want to
work for myself? I really recommend me.
I like that. Give me 1 second. I will have. This is not really. Oh, really? Put a password out there. That's nice, Paul. Gee, I guess I'll have to change that very quickly, won't I? 1 second here. We will jump over to Gil's, and then we are going to wrap this up. Again, I want to thank everybody for joining us here. Here's Gil's website on YouTube. You can go and check out all of his cool videos out here. And he's, we've actually got a few other people. We got Angie Jones out there, who's awesome. I'm going to have to give her a call one of these days, an evil tester. Those guys are all awesome over there.
Yes.
I'm going to go back over here, Gil, again. And I'm going to stop sharing because I got this. This is going to be annoying.
Yeah. Let's stop sharing too.
Or any place that we can reach you, that if anybody wants to reach out and talk to you.
So testinggil.com or everydayunittesting.com will get to me. Gil at testinggil.com. It's the easy way. Social media, whatever, LinkedIn, get in touch with me. I'm still on Twitter somehow. And anyway.
Right. Sounds good. Well, everybody, I'm going to put on my testing mask again and go off and do some cool stuff. It's been a blast. We'll see everybody, I think, next month or in 2 months. And my co-author, just a reminder, my co-author, Larry Goddard, will be hosting the next channel. Larry Goddard and I wrote this book on test automation. I've mentioned it 3 times. And also, don't forget, we also have Matthew Hughes, who's also a good friend of mine, Software Testing Strategies. Please check these books out. Get a chance to take a look at them. And with that, I will say goodbye. Thank you again, Gil. Everybody have a great day. Cheers.
Bye-bye.